Welcome back, Algebra 2. In this video, we're going to be going over how to multiply radicals and simplify them. So let's start off with a few examples. The first example is just with square roots. So let's take the square root of 15x, and we're going to multiply that by the square root of 20x squared. So what do we do in this case? So remember, we've got this property, and this property says that if I've got the nth root of a times the nth root of b, then we can multiply them together, and we'll have the nth root of ab. So that makes this problem pretty simple, at least to start. We got a square root times a square root, so we're just going to multiply what's underneath. 15 times 20 is going to be 300, and then x times x squared, we are going to add the exponents. So 1 plus 2 gives us 3. After we have it simplified like that, I tell my students, okay, we're going to put it together just so we can break it apart. So what is the biggest square that goes into 300? So remember, this first radical is going to contain squares, and it's going to contain variables with even exponents. So 300, biggest square. Do we remember what our squares are? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and the list keeps going. So which of those would be the biggest? Well, in this case, it's going to be 100. So we have 100 here, and 300 is 100 times 3. So the 3 would go in the leftovers. So this one's going to contain all of our leftovers. And then we look at our x's. We need to have even exponents. Well, 3 is not even, so we've got to knock it down a little bit. So let's put, how many can we put out here? The most we can put is 2, and then there would be 1 left over. So now we do that so that the first radical we can take the square root of. So now what do we do next? We've got to take the square root. So what is the square root of 100? Well, that's just 10. And now we're going to take the square root of our variables, the square root of x squared. Well, we're going to take our exponents and divide them by the index. So what root are we taking? If it's a square root, there's like a little invisible 2 over there. So 2 divided by 2 is just going to give us 1. The part over here, that we can't do anything with. That's our leftovers. So we get 10x square root of 3x. All right, here's our next example. This one, the only difference is now we have numbers on the outside. So we're just going to treat those as regular numbers on the outside. We're going to multiply those together. So if I take the 5 and the 4 and I multiply those together, I would have a 20 on the outside. And we're going to do the same thing as before. We're going to multiply our square roots together, combine them under one square root. So 3 times 6 gives us 18. X cubed times x cubed, we add the exponents. That's going to give us x to the 6th. And now we're going to break it apart. So this square root here, we're going to break up into 2 square roots. What's the biggest square that goes into 18? So obviously it's not 25. 16 doesn't work. 9, there we go. 9 is going to work. So we put a 9 there, and 18 divided by 9 is 2. 2 would be left over. And again, this is going to contain even exponents. Well, 6 is even, so that can go out in front. Now we can take the square root of this part. So the square root of 9 is 3. Divide the exponents by 2, so that's going to give us x cubed. And this part we leave alone. Now we're going to take the number that came to the outside and multiply by the number that's already there. 20 times 3 is 60. So we write that. X cubed square root of 2. And that's it for that. We have our final answer. All right, how tough can we make this? Well, now I've got not just 2, but I've got 3 radicals multiplied together. Everything's getting multiplied here, so we just do the same thing. We've just got a little bit more to work with. So we take all the numbers on the outside, the 2, the 3, and the 5. Multiply those together. We've got 30 on the outside. We combine all of our radicals to make one big radical. The square root of 6 times 15 times 2 is 180. And we add our exponents together. Here I've got 2 of them, two different variables. So x times x squared times x is going to be an x to the 4th. And I've got y squared times a y. That's going to give us y cubed. Keep the 30 on the outside. Let's break this radical apart. So what is the biggest square that goes into 180? So check with the biggest. It's not 144, okay, going down. And we come to 36. And our leftover is going to be 5. Whatever we put in this spot in the leftovers, it should not be divisible by any square. So 5, you can check, it's not divisible by. The only thing it's divisible by is 1. 1 doesn't count there. Our exponents, they have to be even, so I can put all 4 x's here, none left over. But the y's, I've got 3 of them, so I could put 2 out in front, and I would have 1 left over. Keep the 30 on the outside. Now we're going to take the square root of this, and we get 6x squared y, dividing the exponents by 2. This part's going to stay the same, 5y. 30 times 6 is 180, so we get 180 x squared y square root of 5y for our final answer. Now let's take some bigger radicals. Let's take a cube root. A cube root times a cube root. Property still applies. This is going to give us one huge cube root. So 6 times 12, multiply those together. That gives us 72. X squared times x to the 4th, add the exponents. That gives us x to the 6th. Y times y gives us a y squared. And we do the same thing. We're going to use our property now in reverse, break it up into 2 cube roots. So now we have to look at the biggest cube. So our cubes, remember, are 1, 8, 27, 64, and 125. Okay, we have enough there. So let's go back. What's the biggest cube that goes into 27? That would be 8. The other factor, 72, is 8 and then 9. X to the 6. Now we want these to be cubes here. And we want our exponents to be multiples of 3. So like 3, 6, 9, and so on. So we get x to the 6. Y squared, is that a multiple of 3? No, it's not, so that's got to go over here. Now we can take the cube root of 8x to the 6. Cube root of 8 is a 2. X to the 6, take 6 divided by 3. That gives us x squared. And we have the cube root of 9y squared. And we've got our final answer. Our last problem, here we have the 4th root. The 4th root of 75xy cubed times the 4th root of 125 x cubed y to the 6th. So again, our property still applies. We're going to make into one big 4th root. And I probably need a calculator. 70 times 125 is 9,375. And that's going to give us x to the 4th, y to the 9th. Add the exponents. And we're going to break this up into 2 4th roots. The same idea applies, but now we want these to be 4th powers. And the exponents need to be multiples of 4, like 4, 8, 12, and so on. And this is still going to contain our leftovers, as always. So 9,375 is a big number, but if you look at where it started from, 75 and 125, you might guess that maybe 5 would work. So, you could write down your list of 4th powers. 5 to the 4th is 625. And if you check, 9,375 is divisible by 625, and it would leave 15 left over. So we're going to put 1625 into our first one. 15 is left over. We go to our variables. X to the 4th, that has an exponent that's a multiple of 4. No x is left over. Y to the 9th, that's not a multiple of 4, but we can knock it down to, what are we going to knock it down to? 8. And that would leave us with 1 left over. Now we can take the 4th root. So this is going to come out to the 4th root of 625 is 5. And divide the exponents by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And we would have the 4th root of 15y. Alright, that's it for this video. Thanks for watching. Bye!